I'm going to forewarn you that this section is a little tricky, but we can do it. So this material here is from section 7.3, which is called trig integration. Because what we were doing is we were involving trig expressions. So that's trig integration. Now, were we using substitution to do these? The answer is yes. You'll notice that today's lesson is called trig substitution. So it almost seems like we should be doing the same thing. But this is one of the cool. In fact, at the gym last night, I was telling another guy working out. He's actually has a daughter that goes here to school too. But anyways, I was telling him about how cool this is. And I think I'm just going to slide right past this and just get right to an example. Okay. Look at this integral. Do you see anything that is triggy in it? The answer is there is no trigonometry, right? It doesn't look like it should involve trig at all. But what we're going to do is we're actually going to, and this seems so backwards to do this, but I'm actually going to convert this to trigonometry, and then it's going to work out. It's just mind-blowing. I wish I would have been the person that figured this out. So I'm going to just tell you right now, you look at this 4 minus x squared, and then you go back to this reference chart, and you try to see which of those that category seems to fall into. Well, it turns out that it's this one right here. You see how it's got a squared? That's a constant squared minus u squared. That's like a variable squared. And that's what we have here. We have a constant squared and then a variable squared. So we're going to let x equal 2 sine, and I'm going to call it theta. And the reason I'm doing that is because of this chart right here. It tells you what to do. Now notice it says let u, I'm going to just call it x because it's just easier for me to do that, equals a sine theta. A is the square root, is the square root of this. What's the square root of 4? Well, it's 2. Now the next thing I'm going to do is I'm going to draw a reference triangle. You do not have to do this, but I'm just telling you right now from my own experience, it helps me out a lot when I do it. Okay, so if this is theta right there, sine is opposite over hypotenuse, correct? Opposite over hypotenuse. So what's opposite? Here, so this is going to be x over hypotenuse, so that's going to be 2. Now you might say, well, Mr. Brown, how'd you get that? Well, here's the thing. Look at this right here. This is the same thing as saying that x over 2 equals sine theta, right? So this is opposite. X is opposite, and 2 is the hypotenuse. Now, if we do the Pythagorean theorem, we can figure out what this third side is. And so you do this squared plus this squared equals that squared. And when you solve it, you'll end up getting 4 minus x squared, which should kind of look familiar. So that's my reference triangle. I hope that kind of makes sense how that came about. Now, I'm going to stop here for just a second and see if you guys have any questions so far. I know it kind of seems really almost bizarre that we would do that. Are you with me so far? So far, so good? Okay, so let's go ahead and continue. Now, if this is x, what would be dx? Well, it'd be 2 cosine theta. And then don't forget to do the d theta. It's just like we're kind of doing u sub. And again, I could have used u here, but I'm going to just use x. It's just easier for me. Oh, by the way, if this is x, what would x squared be? Well, it'd just be 4 sine squared theta, right? So now what I'm going to do is I'm going to take all of this stuff and I'm going to plug it into this integral. And I'll do it in purple now. So this integral is going to become, now what do we got for dx? Well, we did dx. It's right there. It's 2 cosine theta d theta. What was x squared? Well, we know that x is 2 sine theta. So it's going to be 4 sine squared theta. And then we got this square root. Well, 4 is just 4. But what's x squared? Oh, we just did that. It's right there. So now I'm going to write this down, and I'm going to hesitate for a second and just make sure you guys are kind of with me. Notice that what I've done is I've taken everything up here, and I've basically converted it into all trigonometry. Again, this seems like, why in the world would you want to do that, Mr. Allen? Watch. I should probably refresh your memory that there's a couple of things like sine squared theta plus cosine squared theta is equal to 1. Agreed? Similarly, you could say that cosine squared theta is equal to 1 minus sine squared theta just by subtracting, right? Keep that in mind. Would you agree that we could factor out a 4 on the denominator? So that gives us 4 cosine theta d theta over 4 sine squared theta. Now this right here could be thought of as 4 parenthesis 1 minus sine squared theta. So the only thing I've changed between here and here is I pulled out a 4, correct?
But you can change.
But what's 1 minus sine squared?
Cosine squared theta.
It's cosine squared. So in other words, what I'm saying is we could think of this right here as just cosine squared theta. Okay, cool. So things have gotten a little bit better now. Now I'm going to leave the top again completely as it is. And on the bottom, I'm going to still leave this 4 sine squared theta alone. But now here's my question. What will 4 cosine squared theta, what will the square root of that be? Well, the square root of 4 is 2. The square root of cosine squared theta is cosine theta. Oh, by the way, does anything cancel now?
The cosines.
The 2 and the cosines cancel. Now it's getting better. So now we're left with 1/4. I just pulled out the 4. The integral of 1 over sine squared theta. It's gotten better. Does anybody remember what 1 over sine theta is? Is it cotangent? Is
Yes,
it
cotangent.
secant? Or is it
Cosecant.
it's cosecant? So this is 1 over 4 integral of the, not cosecant that way. Cosecant, we typically spell it this way. And you're just thinking, okay, where are we getting at with this, Mr. Allen?
This is crazy.
Does anyone happen to remember? Let me help you guys out. Does anybody happen to remember what the integral?
Isn't it like cotangent squared minus 1?
Does anyone happen to remember what the integral of cosecant squared theta is?
Negative cotangent x plus c.
Now, obviously for you to get that step, you kind of need to know that integral, but here's where things get great. Remember up here I said that since this was theta and it was sine, it was opposite over hypotenuse. Do you guys happen to remember what tangent is? Tangent is opposite over adjacent. What would cotangent be?
Adjacent over.
So what's adjacent to theta? Which it's this leg here, right?
Oh.
So adjacent would be square root of 4 minus x squared over, and then what's the opposite? Holy cow. Notice that somehow we through trig. By the way, you can't do this integral using u sub, you can't do integration by parts, you can't do any of that stuff. This is how you get, isn't that crazy? Who thought of this?
This doesn't matter.
It doesn't even seem like, it seems like laughable that this would even work, but that is the answer. You can check, don't do it right now, but you can do this derivative and you'll get this. So, I mean, you might clean up the answer a little bit here and just say it's, this, and you can even plug it into Wolfram Alpha and check it. That's the answer. It's crazy. I don't know. I just think it just blows me away. Every time I think of it, I'm just like, who would have thought of that? And it works out. Okay. So anyway, so that's an example. I did an example here using sine. And again, the reason I used sine was because this was like a squared minus x squared from this table. So let's look at the next one. So we just did sine, right? What's the next one going to be? It's going to be tangent. Now for tangent, you want it to be something like a squared plus u squared. So let's look at our next example right here. Would you guys agree that x squared plus 9 could be thought of as 3 squared plus x squared? Right? You could, addition is commutative, so you could switch those around. So in this example, I'm going to say x equals 3 tangent theta. And again, I'm going to draw my little reference triangle over here. And again, this reference triangle is not required, but it's been my experience that if you do it, you tend to not screw it up. And if you don't do it, you tend to get things mixed up. Okay. Now we're talking about tangent now, right? Tangent is opposite over adjacent. So what am I going to put right here? I'll give you a hint. It's either x or 3. Which one is it?
X.
It is x. What do I put here?
3.
And then guess what's going to go up there?
X squared plus
The square root of 9 minus x, or 9 plus x squared, which is what we had here, right? You can put x squared plus 9. It doesn't matter. You can check, right? You just take this side squared plus this side squared, but then you have to do the square root of it. So that's my reference triangle. Does that make sense? You want to do all of this stuff before you start trying to do the problem. Figure out if it needs to be sine, or in this case, tangent. Get your reference triangle set up, and now let's go ahead and try to do some of these substitutes. Oh, by the way, if this is x, what's dx?
Isn't it 3 sine or secant squared?
Correct. And then don't forget the d theta. Okay, now let's go ahead and write it in using our trig stuff. So what's dx? Well, it's all that right there. So it's going to be 3 secant squared theta d theta. And then now for this x squared plus 9, I got to plug x squared. So that's going to be 9 tangent squared theta plus 9 to the 3 halves. Okay, you guys remember this sine squared plus cosine? What happens if I divide everything by cosine squared theta?
It'll be tangent x or tangent squared
Tangent squared theta
plus 1
plus 1 equals secant squared theta. You with me? Okay, that's going to come back to help us here in just a second, okay? You can already see it. Okay, so I'm going to keep going. So this is going to give us, I'm going to leave the top alone. And on the bottom, I'm going to factor out a 9. So it's going to be 9 quantity tangent squared theta plus 1 to the, and I'm going to write this a little bit differently here. I'm going to put the square root of this, and that's all raised to the third. So remember, when you have a fractional exponent like 3 halves, that means you're doing the square root and then raising it to the third. Oh, but what can we put in for tangent squared theta plus 1?
secant squared.
Correct. So this right here, we can think of this as secant squared theta. So we get the integral of 3 secant squared theta d theta. Okay, now, what will be the square root of 9 secant squared theta?
It'd be
3 secant, right? But then we got to take that to the third, right? So what's 3 to the third?
27.
27. And then it'll be secant cubed theta. Now look what happens. First of all, what's 1 over 27 going to reduce to? Actually, here, I'm going to stop and let you guys.
Is it 1 over 27?
1/9.
1/9, right? You got a 3 and a 27. And then what are you gonna be left with inside here? Just secant theta, right? But what's 1 over secant? Cosine. Yay. Now this is becoming a lot easier, isn't it? Thank goodness. It was looking pretty scary there for a while. What is the integral of cosine? Sine theta plus c. Oh, what's sine again? What sine?
That's opposite.
Opposite over
G.
hypotenuse. Opposite over hypotenuse. Yeah, let's go ahead and write it like that. So then that's going to be the square root of 9 minus x, or plus x squared, over what, x plus c. So that'd be, let's just say the square root of 9 plus x squared over 9x plus c.
Boom.
Oh, crap. Look what I did. What did I do?
Hypotenuse over
What did I do? Opposite over hypotenuse, correct? What did I write?
Hypotenuse over
I did the other way around. I just screwed that up. I just did, yeah. So let's fix that. I am so sorry, guys. That was just a stupid mistake on my part. Guess why I do all this stuff before class?
That way you won't.
Just so I can catch myself from making a complete idiot. Those need to be flipped over here. And so then this could be rewritten now as just x over 9 square root of 9 plus x. Okay, now we look at it. Again, this is one of those things where you just got to trust the process. Because as you're getting in the weeds here, you're starting to think, oh my gosh, this is a hot mess. Don't forget that this here is like the key, that Pythagorean triple there. Anyways, so we've done sine. We've done tangent. Oops, can you guess what we're going to do next? We've got to do secant. Now here's the thing. Look at secant compared to sine. In sine, it was that constant squared minus u squared. On the secant, it's the u squared minus, it's the switch of those two. So let's go ahead. In fact, you know what? I'm going to do this. Why don't you, I'm going to pause the video. Why don't you see if you can just get this set up real quick? Just see if you can get this set up. In other words, you already know what x is going to be, right? Do your little reference triangle and see if you can start getting this one kind of worked out a little bit. And don't go too far, though, because this one's got a little bit of a twist to it. Okay, so what are we going to let x be in this case? 2 secant theta. Does that make sense?
Yeah.
By the way, let's just go ahead and get dx. What's dx going to be then?
2 secant theta tan theta.
D theta.
D theta.
Okay, let's go ahead and get our reference triangle set up over here. So here's our theta. Remember, secant it's the inverse or the reciprocal of cosine, right?
So,
Cosine is adjacent over hypotenuse, so this one's going to be hypotenuse over adjacent. So the hypotenuse should be x, and the adjacent should be 2, and then this side over here is going to be x squared minus 4. Does that make sense so far? Now we're going to start plugging all this stuff into our formula here, or into our integral. So let's go to purple now. You're going to purple. So in this top thing, we're going to do this thing squared. Now here's the part, I'm going to put this even in a different color because students tend to forget this. Don't forget this dx. You still have to put in this 2 secant theta tangent theta d theta. Okay, so all of that has to be in there. All I've done is I've connected the dots, if you will, and put stuff in as appropriate. Now again, looking over here at this formula, If I minus this one over here, it would become the following. Tangent squared theta equals secant squared theta minus 1. We're going to use that in just a second. Okay? Do you guys agree with that so far?
Yes.
Okay, so this right here is going to become 4 parenthesis secant squared theta minus 1, all in the square root, over all the same stuff. And guys, I am showing a ton of work on all of these examples because I don't want to leave anything out to where students are like, how did you get there? Once you get good at this stuff, some of these steps you can kind of skip. What am I going to put in here for this secant squared theta minus 1?
Tangent squared.
I'm going to put tangent squared, right? And then I'm going to be doing the square root of it, right? So that tangent squared is going to become
2 tangents.
just 2 tangents, okay? Does that make sense?
And I'm stuck right there.
Okay, that's cool. Not cool that you're stuck, but yeah, you get the idea. So this is going to be tangent, 2 tangent theta over 2 secant theta, and then 2 secant theta tangent theta d theta. Okay, and I'm running out of room here, but hopefully, I'm going to stop here a little bit, let me get caught up.
Can you cancel out the 2s?
The 2's and the secants get canceled, right? These 2 guys here.
Oh, I see now. Okay. Yeah, I see.
Now I'm going to pull that 2 out to the front. And we're left with, I think, was that tangent squared theta? Now this is the favorite part, and this is one of my favorite parts of this problem. Now you're probably thinking, well, crap, there's no integral for tangent squared. Hey guys, what's tangent squared equal to then?
Secant squared.
Secant squared minus 1. There is an antiderivative for secant squared, and there is an antiderivative for 1. So this then becomes, in fact, now I'm going to, I'm going to still stay in purple for just one more step here. So this is going to be 2 integral of, and then we said secant squared theta minus 1 d theta. We can now integrate. What is the antiderivative of secant squared?
Is it
Oh.
secant tan? 2 secant tan?
Tangent.
Theta.
Oh, it's just tangent.
Right? Remember, you know the derivative of tangent is secant squared, so the
Oh, yeah.
Yep. So this is going to give us 2 tangent theta, and what's the integral of 1?
Minus x.
It's just x, or in this case, it's actually
Theta.
theta. Now, guys, I'm going to go ahead and write minus 2 theta. I went ahead and I'm distributing that 2, okay?
Let's see.
Okay, we're almost done. We're almost done. This is good. Now I'm going to go ahead and switch back to red here, okay? 2 times. Now, what are we going to put in for tangent? What are we going to put in for tangent?
X.
Square root of x squared
Oh,
minus
yeah.
4.
So this is going to be the square root of x squared minus 4 over 2. By the way, the 2's are going to cancel. We'll get to that in a second. Now here's the other part, and I'm going to do this in a different color because this is a tough part. How do we find theta? What do we put in for theta? Well, here's the thing, guys. Here, this has theta, correct? So if I wanted to, I could say that x over 2 is equal to secant theta, correct? And then if I wanted to, I could say the arc secant of x over 2 is equal to theta. Agreed? And so that's what we put in here.
Oh,
I know, isn't that crazy? Now, guys, I'm going to just let you know something that you maybe haven't ever seen before, which could be this very thing. Have you ever went to Wolfram Alpha and like try to figure out the integral to something, and it gives you some crazy looking thing like this, and you're like, how in the world did it get arc secant in there? This is an example. Anyways, these 2's cancel. So our final answer here is going to be the square root of x squared minus 4 minus 2. And I'm going to write this a little bit different. I'm going to put secant inverse x over 2 plus c. And that ends the lesson. I'm going to stop it there.